In this lesson, we're going to use rounding to help us estimate sums and differences. An estimate is a number close to an exact amount. We use an estimation if we need to find about the answer, but we don't need a very specific number. So looking at this problem, we're going to use rounding to find an estimated difference. So I'm going to look at the first number, 76,310. If the problem doesn't tell you the place value to round to, it's your choice which you would like to round to. In this instance, I want to round to the thousands place. So I'm going to underline the digit I'm rounding to. I'm going to compare the number to the right of that digit to 5 to let me know if I round up or stay the same. Because 3 is less than 5, my underlined digit is going to stay the same. So this number rounds to 76,000. And whatever place value I round the first number to, I also need to do the same for the second number. So I'm also going to round this one to the thousands place. And I'm going to look to the digit to the right, which is 0. And 0 is less than 5. So my 8 is going to stay the same. And this number will round to 28,000. Now I have rounded both of my numbers, and now I can find the difference for this problem. You can see how the problem 76,000 minus 28,000 will be much more simple to solve than 76,310 minus 28,095. I have no difference between those zeros. I regroup from the 7 and turn the 6 into 16. 16 minus 8 is 8, and 6 minus 2 is 4. So my estimated answer to this problem is 48,000. Now I can also figure out a range for a problem with estimation, and to find a range I will use both an overestimate and an underestimate. So an overestimate is greater than the exact answer. That means that I am going to round every number in my problem up, disregarding some of the rounding rules that we know. So in this problem, I'm going to round to the thousands place. So since I'm going to make an overestimate on this side of my problem, I'm going to round all of my numbers up, even though my regular rounding rules would not have me do that. So 6,717 will round up to 7,000. 3,471 will round up to 4,000. And 5,400 will round up to 6,000. Normal rounding rules would give me a different option, but in this case I am looking for a range. So I'm going to have all of those round up. Then when I solve my problem, I have 7 plus 4 is 11, plus 6 more is 17,000. Now I'm going to do the other side with an underestimate. And an underestimate is less than the exact answer. So I'm going to round all of these numbers down, whether the regular rounding rules tell me to do that or not. So 6,717 rounded down to the nearest thousand is going to be 6,000. 3,477 rounded down to the nearest thousand is going to be 3,000. And 5,400 rounded down to the nearest thousand is going to be 5,000. And you can see basically all that I did was I took this underlined number, left it the same, and replaced the other 3 places with zeros. So now when I add for my underestimate, all my zeros stay the same. 6 plus 3 is 9. 9 plus 5 more is 14. Now I have an answer that I can write into this sentence frame. A possible range is from 14,000 to 17,000. Now, if I were to calculate the exact answer for this problem, I would know that my exact answer should fall between 7,000 and 14,000. So finding a range for your estimate can be useful as a self-check to make sure that your actual calculations are accurate. I know that my answer will be between these because all of these numbers for my overestimate are larger than the actual number, and all of the numbers for my underestimate are smaller than the actual number. So my actual answer must fall somewhere in between.